So combining some algebra and some geometry together, one of the examples you may come across your homework is finding interior and exterior angle measures. So there is a rule in geometry that says the measure of an exterior angle of a triangle is equal to the sum of measures of its two remote interior angles. So if I look at this triangle, let's say this is angle A, this is angle B, and angle C over here. Notice the angle C would be interior, A would be interior, B would be interior, but notice that this angle out here is actually outside the triangle, so that's an exterior angle. Now remember, the sum of the three angles in a triangle do add up to 180 degrees. So if this is 150, then this has got to be 30 degrees. So what this tells me that this interior angle and this exterior angle are supplementary because they do form a half a circle. So they have to add up to 180 as well. So if this is 30, then this has got to be 150. So what we pick up on is this exterior angle is equal to the sum of these two. We refer to them as remote as because they're not adjacent to this exterior angle, they're away from it. So these are described as remote interior angles. Notice that these two angles here do add up to equal this exterior angle. So if I look at my drawing, notice how this angle here and this angle here are given as some algebraic expressions, and this angle out here is given. Notice how this is an exterior angle, and these two angles here are interior. So that means the sum of these two angles must equal this exterior angle. So we can write an actual equation for that. So angle A, which is represented by 2x, plus angle B, which is represented by x plus 20, must equal the exterior angle, which is this 3x minus 40. So if we do some math, I don't know why I got 2x there. Sorry about that. Let me clean that up there. So this angle is x, not 2x. Come on, you can do it. So angle A was x, angle B was x plus 20, and then this angle here was 3x minus 40. So these two angles have to equal this exterior angle. So that's a special theorem we have working with angles and triangles. So we do have like terms, and we can write this as then 2x plus 20. I guess that's where I was getting the 2x at. I was already doing some math. Equals this 3x minus this 40. Notice how we simplified each side, but notice how the variables on different sides. I like to pick on little guy. So I would be subtracting this 2x here as long as I subtract a 2x over here to get the variable on the same side. So then we're seeing that we have a 20 over here and we have 3x lose 2x's gives me just an x left over minus this 40. Now my goal is to get the variable by itself, so this minus 40 has to move to the other side of the equation. To get rid of a minus 40, we have to make it a 0, so we have to add a 40 to zero it out, but we have to add a 40 over here. That's that property of equality. What you do to one side of the equation, you got to do the other side of the equation. So if we can clean this math up a little bit, we see that this is 60, and we do have x solved for. So angle A would be 60 degrees. Angle B would be 60 plus 20, which is going to give me 80 degrees. And then this exterior angle, if you will, may have to use angle BCD for that. Angle BCD, since it's kind of not clear which angle we're talking about. So BCD is this exterior angle. Thus, it's going to be 3 times 60 minus uh, 40. But notice how it should be the sum of, this should equal 80, I'm sorry, 60 degrees. This should add up to 140. So if I do this math here, I should be getting 140. So 3 times 60 is 180. If we subtract 40, we do end up with 140. So the two interior angles are 60 and 80, and they do add up to the exterior angle of 140. Okay. So we have that going on here. Okay. So I think that would be good enough for our examples on triangles in algebra.